I think we should just start this review with a graph of kind of a typical cosine graph. So everybody graph 2 cosine of 5 theta. On your mark, get set, go. Okay, plain old-fashioned cosine, just to make sure you started off on the right foot. I like to do it in 4 parts. It makes kind of a valley. It ends at 2 pi. That means halfway would be pi. I think this is a good way to number it because sometimes, you have to like figure out where the marks are. And if you start with this and then you go halfway and then you go half of that, you get pi over 2. And then I like to count it back up and go 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And some people are like, I like 2 pi better. Yeah, until you have to number this spot. And if you have to number that spot, because we're going to shift it, not right now, but later, then you'd need to know, oh, what's after 4 pi over 2? 5 pi over 2. And again, we are going to shift it, but not quite yet. So I'm going to figure out what this 2 has done to me. Well, that just took this 1 and this -1 and change them into 2 and -2. That's pretty easy. This 5 here is going to not multiply everything by 5, but it'll multiply everything by 1/5. So this will be multiplied by 1/5, and then I quickly realize, oh, so my denominators are going to be 10. 10, 10, 10, and 10. Now, if you had been simplifying, if you're one of those people who's like, well, I just want to leave it as 2 pi. Fine, but then you couldn't just put it over 10, And so it's actually quite a bit easier to do it this way. All right, so now I have 1 pi over 10, 2 pi over 10, 3 pi over 10, 4 pi over 10, and 5 pi over 10. And I'm going to ask you to shift this thing, because I'm going to go like this, right pi over 10. So everybody change the problem a little bit, because you would have done everything the same up to here. And now make the problem have a shift in it of right pi over 10. Okay, technique. I think the best way to do this is to draw an arrow for each of the 5 major dots. There's a dot here, 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 and here. And I would draw an arrow in and say, okay, I'm now going to move this to the right. How far is pi over 10? That's how far pi over 10 is, 1 mark. So I'm going to do it, make a little arrow to the right 1 mark on all of them. And then I can just go to the arrow tips and say my new graph needs dots at the end of each arrow tip. That's what I have found is the easiest way to shift something to the right or left. Okay. Now, one last thing I could do, and you would have still done the problem exactly the same to here, is if I wanted to make this the worst, hardest problem on the test, if I said, oh yeah, and there's going to be a shift too. Not a shift, sorry. A flip, a reflection. See how I just put a negative in the front? You would have done everything the same to this moment, but now you do the reflect. So go ahead and throw in a negative, and then make the graph do its thing. Okay, so that negative right there has caused me to need to I already have a black cosine graph and a blue cosine graph, so I guess I'm going to change it to a green. Is there any other choices? No, not really. I could use yellow, but it's, well, I'll try to use yellow. It's really hard to see. I'll make it really dark. All right. And there, non-ideal for color choice, but didn't have much left. Yes?
Are we gonna have to know how to base off of the graphs know what the equation would be?
Yes. So, let's try one of those. So here's a question first. Another question. Thought I saw another hand. I guess I'm wrong. Here's a graph. And it doesn't end at 2 pi like you'd expect it to. It ends at pi. Next, it doesn't end at 1 anymore. It ends at 3. Can you tell me what this equation was? And first of all, I'll tell you, just use sine, because it looks like sine, doesn't it? I mean, it starts at 0, 0. I mean, it looks like sine. So we'll just say, tell me what A sine B of theta minus C plus D, that's kind of your general framework. Tell me what it would be if it was a sine graph. Because clearly it's been stretched. Now you'll have to think through the period. So that one little formula is going to be really helpful. Period is 2 pi over b, right? Does this one have a period of 2 pi? No, so it must have had a b term that changed that. I'll show you how in a minute, but you should be able to figure this out from the formula. Period is 2 pi over b. Pause for a second. Let me give that a shot. Okay.
We always figure it out.
So I think you guys get that this 3 here just tells you the A is 3, right? 3 sine of, and that B, I'm going to encourage you to write its formula out every time. Period is 2 pi over B. And I don't know B, so I can't put B there. But I do know the period, and the period is pi. I know because I can see it's completed a complete cycle in pi. So then I can switch this around and say B equals 2 pi over pi. That's just me solving for B. And then the pi's cancel, so the B equals 2. So this is a 2. Theta minus C plus D. Now, how far has it been shifted? It hasn't been shifted. So you could put a 0 here. You could just not write it. You know, you don't have to say minus 0. You could just not have a C and not have a D because it hasn't been shifted up either. All right. Now here's the real challenge. What if instead I said you have to write it as cosine? That's more of an R3. Even a hard R3, but I think you can do it. Write it as cosine. It's just been shifted, that's all. So here's, if it's cosine, it's still been stretched up 3 times as high, right? So y equals 3 cosine of, well, the stretch thing is exactly the same. It's still completing one cycle, isn't it? It's still one cycle. It's from the start to the end, that's just one cycle. So the 2 is exactly the same. Then how about the shift? Oh yeah, cosine. Remember that deal where cosine would be here, but it's been shifted over there? That's the only challenge, is to figure out how far it's been shifted. It hasn't been shifted up or down, so the D is 0. I'm going to just put plus 0 at the end. How far is that? Well, remember me saying I think this is a good technique. You go halfway. What's half of pi? Pi over 2. And then you go halfway again. What's half of pi over 2? Pi over 4, and that's how far it was shifted. Pi over 4. I'm curious, how many of you got that one right? Not that many. Do you know now? Do you understand it now? If you don't understand it, then say, Mr. Server, can you explain how the pi over 4 happened again? Because I will. Almost always the second time I explain something, people get it. Yes? Which part?
Just the fact
pi over 4 part? Okay. So first off, it is pi over 4 right here because of, well, this is started at a pi and then it was pi over 2, and so that's why this spot is pi over 4. The reason I know that cosine has been shifted that far is I look for the first peak. You know that deal from the lab, you look for the first peak, and it's how far to the right it has been shifted. It's the x value of the first peak. So there's my x value of that first peak. Yes?
And would it always give us like one of the values?
Yeah, you'd have to know what the x is counting by. So like this was even pretty hard. Like I bet you on the test they would even say that this was pi over 4, but you'd have to like figure out that, oh, it is cosine but shifted. All right, so there's it in cosine. Now I feel like we're ready for a few of these. Just look at that drawing for a moment. See if all of it makes sense. Just like look at each thing, like that's the amplitude. Does that make sense that that's the amplitude? Okay, yep. That's the period. It goes from the peak to the peak. Now, you could have actually done the period from the trough to a trough. The phase shift. And they wanted you to shift it left in this problem. We often shift it to the right, but either way it can work. And the D is the vertical shift. Are all of those making sense to you? Okay, good. Let's go to the next page. Everybody find this page in the notes. And sine here has been shifted. All of these can be sine. One of them looks like it's cosine. Graph 2 looks like it's cosine, but it can be sine, just shifted. So try to write me the equation for each of these. They're all sine, but something's happened to sine on all of them. None of them are just normal sine. But I will tell you this, as far as I know, each of them only has one tweak. It's like, oh, it's 2 sine, or oh, it's sine of 2 theta, or it's got a negative in it somewhere. So don't think you have to find like 16 changes. It's just sine of theta, but there's something changed about it. There's more than one way to do some of them too. I'll pause for a minute while you try those. Okay, let's try a few different people here. Use Dice of Destiny and seating chart. Figure out who is destined to tell me each of these graphs. And if you get stuck, I'll help you, but it's your problem. Row 1, person 4, Mr. Hopkins. Can you tell me? A negative there would take normal sine, which looks like that, and it would flip it over, and you're absolutely right. Good job. But there's another way. If this had been sine, do you get sine would be this part? That's where sine would normally look like, right? And so couldn't you kind of argue that that sine has just been shifted to the left? So if anybody wrote, I want it to be sine, but shifted to the left, which would be plus, and how far? Well, it's half of 2 pi, which would be pi. That's also a correct answer for it. I don't know if did anybody do it that way? Ooh, a few of you did. Nice job. Yes?
Could it have been done negative, like shifted the other way?
Oh yeah, you could shift it both directions. You are correct. It could have also been minus pi. If you would have shifted it to the right pi, then I would have taken this part right here and shifted that to the right. Maybe that's not the right part of it, but you'd been able to shift it left or right. You are correct. All right, now I'm not going to go over every possible answer for each graph, but for this one, I would have just taken sine, which normally looks like that, and I would say, oh, that's sine, which would have been here. And it looks to me like it's shifted left one notch, which would be pi over 2. So I'm going to just do left pi over 2. Could it have been right? Yes. Somebody tell me what you think it is if you did right. Okay, nobody did it that way, then I won't do it that way. Okay, on to graph 3. That's this one. It looks to me like the whole thing just got shifted up because it's normal sine, but it's been shifted up. How far? Well, I take the dotted line down the middle, which I call the center line, and it looks like it's been shifted up that far. If I look really close, there's a 2 right there. It's been shifted up 2, so plus 2. And last but not least is this one, which looks like it's been stretched. And if that's 2, then it looks to me like that would be 3. And therefore it's 3 sine of theta. All right, cool. On to the next page. This is a concept checklist. If I asked you to graph this with any like tweaks to it, we've done sine and cosine so much that if you can't do that by now, that's on you. But how about cosecant, secant, or cotangent? I'm afraid those might be the ones that get people more often. So let's try one, not of each, but let's try a cosecant. 3 cosecant of theta. Let's make it 4 theta. Everybody graph 3 cosecant of 4 theta. And yeah, you're going to start by graphing something else. So what is the sister function that you should start graphing, Mr. Good? Sine. All right, so we're starting with sine. And then that'll tell you where the asymptotes are and stuff. So I'll pause for a minute and give you some time to try that one. Okay, let's see how you did. I'm hoping you had asymptotes there, and there, and there, because that's where sine, the sister function, hits 0, and cosecant is 1 over that. So 1 over 0 makes the asymptote. Then you make these loops where it touches at 1. Oh, wait. Well, I'm just going to start with the loops because those spots would be 1 and -1. But now it's been relabeled because of this 3 here. So this will be a 3 and a -3. And now this would have been a 2 pi and a pi and a pi over 2, and I'm going to count it up. 1 pi over 2, 2 pi over 2, 3 pi over 2. I strongly recommend this method, 4 pi over 2, because then I can just multiply them all by 1/4. So this would be 1/4 gets multiplied right here, right? So then the 4 times 2 becomes an 8. So this becomes pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8. If you had tried to be fancy and simplify those earlier, you couldn't have just changed all their denominators to an 8. So that's why it's good to not reduce until the very end. All right. Good. That graph, the blue part, is cosecant. Now, I'm conflicted about whether or not a person has to erase this because it's kind of like part of showing your work. But if you erased it, I would say, yeah, I understand. The cosecant does not actually want the sine in there. That would actually be 2 graphs on 1, so best to erase it out. Any questions? Okay, the one that I'm most terrified about is not tangent, because I think most people can do tangent, but it's cotangent. You want to do tangent? All right, we should practice tangent. All right, everybody graph just a regular 2 tangent, just to keep it simple. One little change. We'll practice tangent first, and then we'll do cotangent. Okay, so you're in the middle of the test, and you're like, I cannot remember how to graph tangent. Well, do you remember that tangent is sine over cosine? I'm just curious if anybody went back to that. Did anybody go back to sine over cosine? All right. So then if you have sine over cosine, then you know that cosine is the thing that's key, because cosine hitting 0 will cause this thing to not exist. So here's the graph of cosine. It starts here, goes down, goes back up again, and then it's up like that. And whenever that thing hits 0, that's what causes the asymptotes. So I can back this up and go, this is where 2 pi is, and this is where pi is, and this would be where pi over 2 is. So that's where the asymptote is, at pi over 2 and negative pi over 2. Did anybody remember? Pi over 2 and negative pi over 2. Like 0 people knew what to label it? Seriously? Okay, I'm going to ask that again, for real. Did anybody have the asymptotes labeled properly? Okay, good. It's more than that. All right, it wasn't 0 people, but it was less than half the class. All right, so I guess we better have you memorize this tonight because the test does include tangent. Yes?
So I have to label my asymptotes as negative 2 pi over 4. Will I get points off if I forget?
Is 2 pi over 4 the same as pi over 2? Yes. So remember how I said I like it when you number like that. That's just being smart. All right, so this is what tangent looks like. And do you have to have any y-axis labels? Yes, you do. You have to label the x and the y. So at some point, you should have said this hit 1 and it hit negative 1. And I'm going to put a dot right there and a dot right there. And then there's one last thing. You have to have the x labeled above and below that. So what's half of pi over 2? Pi over 4. And I agree with you 100%. You said I'd like to label it 1 pi over 4 and 2 pi over 4. And I agree. I love it. 1 pi over 4 and 2 pi over 4. That's the same as pi over 2. Okay, cool. Then if I were to do some kind of a stretch, it would be much easier. Or, in fact, I'm going to ask you, what's the next asymptote at? Like this one over here. It'd be a lot easier to use her way of counting by pi over 4s. And the completely wrong thing is 1 pi over 2 pi over 4, 3 pi over 4. No, that's too far away. That's not 3 pi over 4. You know what I mean? This is a huge gap. How big is that gap? Well, it's actually the same as this, which is 2 pi over 4 plus another 2 pi over 4 is 4 pi over 4. This gap is 1 pi. So this has to be 1 pi in between those two. So bottom line, you should have labeled this one as 3 pi over 4, and this asymptote would be at 4 pi over 4. Why would you ever need to do that? What if you had to shift the whole thing to the right? Yes?
So, but
Did I do it wrong?
I think
You're right. I think I did.
wouldn't it be
Yep.
8?
Yep. Let me make more marks. Sorry. Yes, I'm glad you said something. All right. So, and this isn't just like an offhand, like, I do that sometimes, just an offhand comment. This is an important topic, so pay attention. All right, so if this asymptote here was at 2 pi over 4, then I've got to go over pi to get to my next asymptote. Do you guys get that? That they're pi apart? Because this is half of a pi, and here's another half of a pi, so they are pi apart. How many pi over 4s is pi? 4 pi over 4. So if I was 2 pi over 4, then I got to label this as 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. Sorry about that. And then that does simplify down, of course. All right. Yeah, that'd be an easy mistake to make. Now, I understand some people feel like I skipped an asymptote, but I didn't, because the asymptotes are how far apart? Here to here, 4 pi over 4s. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 is apart, right? So if I was at 2 pi over 4, I have to go over 4 pi over 4 before I hit my next asymptote. Okay. All right. So now let's do... Wait, I never did this. I had a 2 in front, so you just have to put a 2 here and a 2 down there. So there. Okay, now let's do cotangent. Hint, Cotangents and asymptotes are in different places. Still got asymptotes, but they are not like here and here. They're somewhere else, because cotangent is not sine over cosine, it's the other way around. So figure out where the asymptotes are and just graph plain old-fashioned cotangent, because I believe that once you had it done, you could stretch it and move it and flip it and all that good stuff. So just graph cotangent for me. Pausing while you try that. Okay, so here's where the asymptotes are and why I know. If cotangent is cosine over sine, then wherever sine hits 0, so once again, like so often, I'm going to start by graphing sine. If I was graphing cosecant, I would start with sine. I mean, there's a lot of times I'd just start with sine. And then I go 2 pi and 0. And why am I only caring about those spots? Because that's where the asymptotes will be. When that sine hits 0, that's where the asymptotes are. Now I can erase sine back out again, because I don't really need the sine graph. I just needed to know where the asymptotes go. And then cotangent is a flip of tangent in a way, and that means that it goes this way, whereas tangent goes the other way, in case you're forgetting. Tangent went like that, you know, kind of rising as you go from left to right. So cotangent falls as you go from left to right. And now, is that right? Yeah, but it's a little too simple. I need some more numbers. So I need to label a spot here where it'll hit 1. And I'll say that this is where -1 is. And this middle spot needs a label, and this spot needs a label, and that spot needs a label. And again, I've tried to teach you to start with your biggest number, like 2 pi, or in this case, pi, and then go halfway and say this must be pi over 2, because it's half of pi, and then this must be half of that, pi over 4, and then count it up. 1 pi over 4, 2 pi over 4, 3 pi over 4, and this last one is really 4 pi over 4. There. And that's got all the labels. Okay. Any questions about that? All right. We're getting there. Now, the lab. What, did we stop talking about the test? No, the lab is on the test. Meaning, there's the same type of questions that are at the lab are on the test, where I give you a high spot and a low spot, and you have to like make an equation using cosine. Well, so my point here is this. There is a worksheet that you can do for tonight's homework, and it's good, but I know it kind of loads you up tonight, but I'd also finish my lab tonight. Why? Because if you understand how to do the lab, you understand how to do one of the questions on the test. It'll help you prepare for the test. Kind of dumb to wait until after the test. Technically, the lab isn't due till Friday, but if you wait till Thursday night after the test is already over with to finally realize how to do this, that'd be dumb. All right, so let's say I give you a high spot and a low spot. Let's say at time 3, I'm just going to keep it simple, I have height 100. At time 9, I have height 30. Now, what I always do is I draw in my graph like that. I just draw it in there. Even though they just told me 2 times, I make a little sketch like this, and then I write my cosine equation. So everybody, try to write me an A cosine of B theta minus C plus D equation for this one. I'll pause for a second. Well, you write me a sinusoidal. We always use cosine. Why? Because this shift right here can be the C. If you did it with sine, it'd be way harder. You'd have to figure out how to take the low spot, and anyway, it could work with sine, but we're not going to switch horses now. Pausing while you try that. Okay, so here's how you're going to do this one. First off, we need to figure out the A And the a term comes from this dotted line that runs down the middle. So that dotted line that runs down the middle has to be exactly between 30 and 100. So to do that, I'm going to average the 100 and the 30. So 130 divided by 2, it's almost like 140 divided by 2, which will be 70, a little less, so 65. And I'm going to double check that and say, how far apart are these two? Well, that would be 35, right? And would this also be 35? Yes, it would. And that is helpful because that's the amplitude. So y equals 35 cosine of b theta minus c plus, and now I know this. This has been shifted from the 0 line, which is where that would have been a normal cosine, up to 65. Okay, the next thing that's pretty easy is this has been shifted over to the right 3, and therefore that's the c. So I'm going to go erase my c and put in a 3. And then last but not least is the b. So b is related to the period. So I always have kids write this formula. Period equals 2 pi over b. And the period in this case, I can tell by saying it went from 3 to 9, and that's a 6, but that's only halfway done. That's not a full period. That's only from the peak to the trough. So I got to double that 6 and make it 12. So the period's 12. So I say 12 equals 2 pi over b. So then b equals 2 pi over 12. And that means b equals pi over 6. And so b was pi over 6. On your lab, remember we're allowing you to just say that the period is 365, and that will make that a lot easier. All right, so there is an example of how you'd take a high spot and a low spot and write the cosine equation for it. All right, now the homework for tonight is a review worksheet. It's got a key. It's strongly recommended. It's going to help a lot if you do that to get ready for the test tomorrow. And that's all I got for you for the video for today.